Hello everyone. We are going to talk about acid rain and ozone layer depletion in the today topic. What is acid rain? Acid rain is the rain or any other form of precipitations such as snow, fog, sleet or dew that is more acidic than normal because it contains dissolved acidic gases, mainly or especially sulfur dioxide gases and nitrogen oxides, NOx. We also used to say NOx, oxides of nitrogen or nitrogen oxides. So we can say the normal rainwater. Normal rainwater normally, as we know, the carbon dioxide is available in the atmosphere. So what happens when pure rainwater is actually we can say pure rainwater is slightly acidic. The pH is less than 5.6 because CO2, which is available in the atmosphere, dissolves with the rainwater and forms the carbonic acid S2CO3. Normally, this mild acidity is natural and harmless. Whereas we can see the other gaseous pollutants like sulfur dioxides and oxides of nitrogens, how they are going to create the acid rain. Let us see the formation of acid rain when air pollutants such as sulfur dioxides or nitrogen oxides or oxides of nitrogens that may have NO and NO2 are released into the atmosphere, mainly for burning of fossil fuels like coal, oil, petrol, diesel, or industrial processes, power plants, factories, refineries, and vehicle exhaust. So in the atmosphere, these gases react with oxygens and water vapor to form the uh, following acids. So what are the various types of acids which are going to be formed? So first one we can see formation of sulfurous acid. When sulfur dioxide SO2 dissolve in water droplets in the atmosphere, we can see here SO2 is in the gas form, water in the liquid form. Where it is going to be dissolved, it forms the H2SO3, that is the sulfurous acid. AQ is nothing but aqueous dissolved in water. So it can make the rain slightly acidic. The sulfurous acid can make the rain slightly acidic. The next we can see the formation of sulfuric acid. So in the presence of oxygen from air and water vapor, sulfur dioxide reacts and how it is going to form the sulfuric acid. You can see the SO2 in the gas form, oxygen in the gas form, water or water vapor liquid, L is the liquid, then it is going to form the S2SO4. So it is a strong acid. Sulfuric acid is a strong acid and it greatly increases the acidity of rainwater. So next, the component of the acid rain. Next, gases, oxides of nitrogen, as I told you in the beginning, it is also going to form the nitric acid. At high temperatures, such as vehicle engines or power stations, nitrogens from the air reacts with oxygen to form the nitric oxide, NO. It also happens in the power stations. It emits through the chimney of the thermal power plants. So you can see here the nitrogen which is already available in the atmosphere due to the high temperatures, it is going to react with the oxygens and form the nitric oxide NO in the gaseous form. This nitric oxide is further oxidized in the atmosphere to form the nitrogen dioxide NO2. So NO and oxygen is going to be converted into NO2. Further, we can see this nitrogen dioxide then reacts with water vapor S2 in the atmosphere to form a mixture of nitric acid and nitrous acid. So we can see this formula, these reactions, nitrogen dioxide with water, the HNO2 and HNO3 both are the aqueous solution. So in the atmosphere, HNO2 is quickly oxidized to HNO3. So overall, the main product is only nitric acid. So these acids, when forms in the atmospheres, mix with rainwater and fall to the ground as a acid rain. So what we found in these two slides that how the acid rain is going to be formed with the different gases, that is oxides of nitrogen and sulfur dioxides. How these gases are going to react with the water vapor or oxygen available in the atmospheres. So now we can see what are the various effects of acid rain. It causes deterioration of building, especially made up of marble. Monuments like Taj Mahal. Crystals, so normally what happens? Crystals of calcium, magnesium sulfate are formed as a result of the corrosion caused by the acid rain. It damages metals and car finishes. Aquatic life, especially fishes, are badly affected by lake acidification. Aquatic animals suffer from toxicity of metals such as aluminum, mercury, manganese, zinc, and lead, which leak from the surrounding rock due to the acid rain. Normally, what happens when the acid rain falls on the rocks, these heavy metals are going to be released, and due to that, it will have impact on the aquatic animals. The next, it damages the foliage and weakens trees. It makes trees more susceptible to stresses like cold temperature, drought, etc. Many insects and fungi are more tolerant to acidic conditions. Hence, they can attack the susceptible trees and cause diseases. Acid rain. How we can control the acid rain? So first we can see reducing emission of pollutants. So use of low sulfur fuels. Use of low sulfur coal or desulfurized oil and gas to reduce SO₂ emissions. So this can be carried out. Low sulfur fuels we can use so that emission of SO₂ will be reduced. The next we can see desulfurization of flue gases. Industrial plants and power plants can install scrubbers that remove sulfur dioxide from the exhaust gases. So what is going to happen? We are going to use normally limestones in the scrubbers, that is calcium carbonate, to remove the sulfur dioxides. So ultimately, the sulfur dioxide is going to be converted into calcium sulfate, right? CaSO3. The third, we can see catalytic converter in the vehicles. Vehicles should be fitted with catalytic converters to reduce NOx emission, oxides of nitrogen emission, by converting them into nitrogen and oxygen before release. So this NOx oxides of nitrogen are going to be emitted from the vehicles. So before emissions, it will be converted to nitrogen and oxygens, so that it will have less impact on the environment, or we can say the acid rain will be reduced. Use of alternative and renewable energy resources. Replace fossil fuels and clean energy sources such as solar energy, wind energy, and hydroelectric power, nuclear energy. So this will also help in the acid rain control. Liming of lakes and swales to neutralize acidity. We can use the lime, can be added to acidified lakes and soil. This helps to restore the aquatic life and improve the soil fertilities once the soil has gone through the uh, effects of acid rain. In that case, we can use the lime either in the lake, or if the soil has been affected, in that case also it can be used for the control of acid rain, or once it has been affected by the acid rain. Next, our topic is the ozone layer depletion. The ozone layer is a region of the stratosphere that contains high concentration of ozone molecules. As we know, above the earth, above the ground surface, the troposphere is there, and above troposphere, the stratosphere exists. And in the stratosphere itself, the ozone layer is there. So normally, ozone layer, what is the function of ozone layer? What it does? It absorbs most of the sun harmful ultraviolet radiations, protecting living organisms available on the earth. In the 1970s, what happens? Scientists began to suspect that certain human-made chemicals were damaging the ozone layer. In 1985, British scientists from the British Antarctic Survey discovered a dramatic thinning of the ozone layer over Antarctica, which is called as ozone hole. The thinning is called as ozone hole. So during the southern hemisphere spring, September to November, up to 95% of ozone in some area was found to be depleted. Later studies showed that ozone depletion was also occurring in Arctic region, that means area around the North Pole and mid-latitudes, the zones between the tropic and the polar regions. The primary cause of ozone depletion was identifying the contribution of the chlorofluorocarbons gas and related to compounds, other related compounds, which release chlorine and bromine atoms in the stratosphere and destroy the ozone molecules. So we can see here why stratospheric ozone is important, or we can say why ozone layer is important for us, or let us see what is going to happen under this heading. The ozone in the outer layers of the atmosphere, approximately 15 to 35 kilometers from the Earth's surface, shield the Earth from the harmful effects of the ultraviolet light radiations. Normally, ozone absorbs ultraviolet light and split into the oxygen molecules and oxygen atoms. We can see here O3 is going to be break up into O2 and O. Oxygen molecules are also split by the ultraviolet light further to form the oxygen atoms. So the O2 is the oxygen atom is molecule is going to be split into the oxygen atom. So normally a recombination of oxygen atoms, these oxygen atoms and oxygen molecules allow ozone to be formed again and to be available to absorb more ultraviolet light. This process goes on continue, right? You can see here how the ozone layer is or ozone is going to be formed. This series of reaction results in the absorption of 99% of ultraviolet light energy that comes from the sun and prevents it from reaching to the Earth's surface. Less ozone in the upper atmospheres result in more ultraviolet light reaching the Earth's surface. Definitely, ultraviolet light is strongly linked to the skin cancers. So more ultraviolet light reaching to the Earth's surface, that means it is going to have an impact on the human being skin. But it means the people are going to be suffered with their skin cancers and contracts in humans and increase mutation in all living things. Contracts, what do you mean by contracts? Cataracts, it is called a cataracts. Contracts, cataracts are clouding of the eye's natural lens. Because of this clouding, light cannot pass clearly through the lens in our eyes, resulting in blurred or dim visions. We cannot see properly. So this is the a type of disease in the eye, cataracts. So next we can see ozone destructions. Which gases are responsible for the destruction or damage or depletion of the ozone layers. So we can see here chlorofluorocarbons play a major role in depletion of the ozone layer in the stratosphere. CFC, chlorofluorocarbons, and similar compounds, they're the halogens, which are used in fire extinguishers and carbon tetrachlorides, are very stable in lower atmospheres. But when they eventually reach to the stratosphere, they are broken down by the ultraviolet radiation or releasing chlorine atoms. These chlorine atoms is harmful for the ozone layer. These chlorine atoms act as a catalyst in reaction with the reaction that destroy the ozone molecules. We can see this equation. The chlorine reacts with the ozone. It forms the chlorine monoxide and oxygens. Further, this chlorine monoxide reacts with the oxygen atoms to form the chlorine atom again is going to be formed and producing more oxygens. So what is going to happen? This free chlorine atoms is mainly damaging. It is going to have an impact on the ozone. So the chlorine atom is regenerated and can repeat this cycle many times. Each chlorine atom can destroy thousands of ozone molecules. This process not only reduces ozone concentration, but also prevents new ozone formations because atomic oxygen is removed in the reactions. It is removed in the oxygen in the reaction. So what is going to happen? It takes 10 to 20 years for chlorofluorocarbon to rise into the stratospheres because it takes 10 to 20 years. Normally, it is available or it is generated in the at the ground surface, and it takes 10 to 20 years to meet to the stratospheres. So once it reaches there, once rise there, this CFC can continue to destroy ozone up to 120 years once it enter into the stratospheres due to their long atmospheric lifetime. So actions to protect the ozone layer. What are the actions which we should take to protect the ozone layer depletions? So or what actions have been taken for this, we can see. So the development of alternatives. In 1991, a chemical company, which name is DuPont, DuPont, developed a new refrigerants in place of CFC, chlorofluorocarbons, which was used in the refrigerators, new refrigerants that do not damage the ozone. These safer alternatives such as hydrochlorofluorocarbon, HCFC, and hydrofluorocarbons. These two alternatives were developed as a refrigerants. Begin replacing chlorofluorocarbons and refrigerators and air conditioners worldwide. Many nations, including United States, adopted these alternatives quickly. So, ban on CFC production. In 1996, the United States and many other countries stopped producing chlorofluorocarbons completely. As a result, the use and emission of CFC have declined sharply. So international agreements were also made. The Montreal Protocol 1987 was a landmark global treaty to phase out the ozone depleting substances. It is considered one of the most successful environmental agreements ever made with nearly universal participation by different countries. What are the positive outcomes due to these alternatives? And we can say this global treaty. Due to these actions and rapid technological progress, CFC concentration in the atmospheres are decreasing. The ozone layer is gradually recovering, and ozone hole over Antarctica has shown signs of stabilization in recent years. Scientists expect that ozone layer to return to its pre-1980 condition by the middle of 21st century if current policies are maintained. So the scientists are expecting by middle of the 21st century, we can recover whatever the damage has taken place. As far as the ozone layer is concerned, it will be recovered by the middle of 21st century. Now, the next we can see what are the effects of ozone depletions. The ozone layer acts as a definitely protective shield in the stratosphere, which absorbs most of the sun's harmful ultraviolet radiations. When the layer becomes thinner, more UV radiation reaches the Earth's surface, leading to several harmful effects on the humans, animals, plants, and materials. So first we can see the effects on human health. The skin cancer, increased UV ultraviolet radiation exposure damage the skin cell and can lead to melanoma is one of the disease and other skin cancers. Cataracts is also one of the disease. UV rays cause clouding of the eye lens, leading to impaired vision or blindness. The next effect on the human health, it weakens the immunity system. Excessive UV radiation can reduce the body's ability to fight the infection and the diseases. So immunity is also going to be decreased by the ultraviolet radiations. Sunburns and premature aging. Higher UV exposure causes skin burns, wrinkles, and loss of skin elasticity. So next effects of the ozone depletion we can see on the animals. UV radiation can damage the eyes and skin of animals, same as to the humans which we have seen here. Aquatic organisms such as plankton, fish larvae, and amphibians are particularly vulnerable because UV rays can penetrate shallow water, affecting their development and survival. Disruption at the base of the aquatic food chain can affect the entire marine ecosystem. So next effects we can see on the plants. Excess UV radiations can interfere with the photosynthesis, reduce plant growth and crop yield. Sensitive plants may show leaf damage, reduce nutrient contents, and lower productivity, affecting agriculture and the forest. So, what are the effects on the materials due to the ozone depletion? The UV radiation causes degradation of materials such as plastic, rubber, wood, paints, and fabrics. All things are going to be damaged due to the UV ultraviolet radiations or due to the ozone layer depletion. This leads to fading, cracking, and weakening of these materials, reducing their lifespans and increasing maintenance cost. So effects on the climate is also going to take place. Although ozone depletion itself is different from global warming, but both are linked atmospheric issues. Definitely, ozone depletion and climate change already we have discussed in the previous lectures. So both are the atmospheric issues. So some ozone depleting substances are also the greenhouse gases which contribute to climate change and global warming. So what we discuss in this topic today, what is acid rain? What are the various gases responsible for the formation of acid rain? What will be the effects of acid rain and how we can control the acid rain? We also talked about the ozone layer depletions, how ozone layer depletion or when the ozone layer depletion was detected, why a stratific ozone layer is important for us, which gases are responsible for the destruction of ozone layers, what actions to be taken to protect the ozone layer, and what are the various effects due to the ozone depletions. So these topics we discuss in details in the today lecture. Thank you.